Now, in the current session, we are discussing about consequences of applying access specifiers and modifiers on methods. Before that, we discussed about class, variables, constructors, and now we are talking about applying access specifiers and modifiers on method and their consequences. Coming to the method declaration, we saw class declaration, we saw variable declaration, we saw constructor declaration. Then we are saying method declaration. Coming to the method declaration, same as the previous constructs, method also begins with access specifier first. Method also begins with access specifier first. Like any of the four access specifiers, like private, default, protected, and public. Then followed by the method can prefix with access modifier. Please notice that I'm placing access specifier and access modifier in angular bracket. That means that writing access specifier and access modifier to the method are optional. Only if you observe the syntax, return type is mandatory, method name is mandatory. Again, all the parameters are optional, and mentioning the exceptions list in the throws class is also optional. So coming to the access modifier, which access modifiers can be applied on method? Specifiers, private, default, protected, public. Okay. Coming to the modifiers, to method we can apply abstract access modifier. Abstract is allowed. Final is allowed. Abstract means no implementation. Final means that implementation is the last implementation, and then that implementation cannot be further overridden. The next final, static. Most of the final combination, class constructs, prefix with static also for better memory utilization. Okay, and the next, what are the modifiers? Abstract, final, static. Transient, volatile are only specific to variables. What are the last two leftover modifiers are abstract and native and synchronized. Native and synchronized. So native and synchronized. So altogether, how many access modifiers we can apply on method? Abstract, final, static, native, synchronized. 5. Access specifiers, private, default, protected, public. The next, written above the method. Written above the method can be any written type, right from the byte to short to int to long to float to double, char, boolean, array, any class type. These are all the possible written types of the method. If you don't want to return anything from the method, if there is no return type to the method, at least the method return type should be mentioned as void. If there is no return type to the method, please mention return type as void. Otherwise, the return type of the method can be of any class type. It can be any array. It can be character or boolean. It can be boolean to double. And any primitive, any secondary, and void. Data types can be used as a return type. Then followed by, while writing the method, we must always write method name. And it is a convention but not mandatory. We must always write method in a camel case convention. For example, verify and grant leave. Here is a method name called verify and grant leave. And verify, if leaves are available, then you grant the leave. If employee is entered and which date, how many days you want to apply leave. So the method internally contains so much of logic. For this employee, it will fetch the number of leaves available and number of leaves he applied now. That information the method can retrieve, process, and can grant something. But while writing the method, if you observe carefully, I've written verify the V starting letter in small letter. Verify V small letter and A cap letter. Get G, grant G cap letter, leave L cap letter. Verify and grant leave. A, G, L are cap letters, V is small letter. So this type of convention is applicable to variables and methods. We call it as camel case convention. So that is a method name. And method name, and while writing the method name, we need to follow camel case convention. That is one major rule we need to follow. And second one is while writing the method, instead of writing method name as print or ABC or XYZ or show, something like that, it is always recommended, it's always a coding convention. The method is always recommended to begin with a verb first, followed by a noun. Verb followed by noun combination should be always used as a convention while writing the method. If you observe my previous method, I started the method with a verb called verify. Okay, please go and verify. And then another verb, and then grant. What to do? The noun is leave. Leave to the employee, you grant. Similarly, calculate salary. Calculate is like what operation you want to do. Add, subtract, multiplication, division, modify, find, delete, get, calculate, show, print. And the method must always begin with the action first, followed by action. Now, whatever on the now you want to perform that action, that you write as a second word in the method. So, such a convention followed methods always follows a good naming convention. Calculate salary, and the next verify and grant leave. These are all some of the combinations of verb followed by noun combination of naming convention while naming the method. Plus Camlick's convention also should be followed. Then after writing the method name, use parenthesis. And in the parenthesis, as you already know, the constructors and methods look similar. The constructors and methods always takes parameters. While writing the parameter type comes first, the next parameter name comes next. Parameter type, parameter name, and so on. After we can write as many number of parameters as we want to write. Next, after completion of the method, use parenthesis and mention all the list of possible exceptions that our method throws. You write all the exception names as a list of here. This is called as throws class. Throws class reports exception. What throws classes? In the exception handling, we will especially discuss about how to raise exception, how to handle exception, how to report exception. All that we will discuss in the exception handling topic. But at the end of the method parenthesis, in the throws class, we will mention all the list of possible exceptions that our method may cause. In this method, we may write 5 to 10 to even sometimes hundreds of thousands of lines of logic also. Because in the previous example, verify and grant leave, that the employee ID may be wrong, the date passed may be wrong, the number of leaves written passed may be wrong, leaves available may be insufficient. So there are different causes. Or database connectivity may be a problem, or that payroll system connectivity may be there may be a network problem in payroll connectivity system may be a problem. So while implementing the method implementation may consist of tens to hundreds to thousands of lines of code. So while writing the method, whichever exceptions we encounter, while writing the method only, we'll come to know what are the exceptions that are possibly raised here. So the soon you recognize any exception while implementing the logic, please mention all the exception class names in the throws class. That is why throws class is called as a reporting exception or reports exception. Throws class reports exception. throws class reports exception. Throws class reports exception. And the purpose of mentioning the throws class with all the exceptions is whoever using this method, who are calling this method in the API documentation, especially of any method API documentation, if you open, always left hand side, the developer will see the access specifier prefix, public or private or default protected. Based on that, he will judge whether I can able to access this method or not. The next abstract, no implementation. Final, I cannot override. Static, I can access the method with class name. Then return type. Based on the return type, he'll judge whether to take the return value of the method into some variable or not. The next method name, all the parameters he'll see. Then all the list of exceptions mentioned in the method declaration statement itself he'll observe. And he'll come to an idea, okay, how to access this method. With object dot I need to call the method, or with class name dot I need to call the method, or within the package I have to access, or outside the package I have to access, or I cannot access even within and outside the package, or is the method is having implementation or not, or its implementation is final. The developer in the first line of reading the method declaration statement itself will completely come to know that how to access the method, but that declaration statement cannot tell how the logic is internally implemented. That may be even thousands of lines of code. So this is the syntax of the method. And coming to a small example given here, here is a method called add with void written type, with no specifier and modifier, and with no parameters. The add method with a void written type, add method with no parameters. Void written type add method with no parameters. There are no parameters in the method. Coming to this next one, public double divide int I comma int j. Divide is a method into which if you pass two integer variables, suppose if you pass 10 by 2, the result is not 5, the result is always 5.0. At any two integer values, if you divide, the resultant output will be always a floating point value or double, but not a primitive int. So if you pass any two integers, the return type of the divide method is double, but the two, while declaring this method, I may not be implementing. If I don't implement the method, I'll simply put semicolon at the end. Methods whichever suffix with semicolon at the end, they must be assumed as abstract methods. Means unimplemented methods. So if you just declare a method without body, and if you don't mention abstract, compiler will immediately gives error saying that divide method must be declared as abstract, or the method must provide a body, its implementation, by enclosing in a flower vases. So okay, so we declared the method as abstract, and abstract method means it's not implemented. Why method is also reporting throws arithmetic exception? Because as an experienced developer, I know that if any integer value divided by another integer value for right, the numerator divided by denominator. If the denominator value is greater than 0, division will be successful, negative also division will be successful. But anything divided by 0 causes an arithmetic exception. Cannot divide 0. Even in the normal Windows calculator also you can try 10 divided by 0, what happens? Cannot divide by 0. That error will come. In the programming, what kind of error will come? In Java programming, the errors raised at runtime are called as exceptions. So usually such exceptions are handled by arithmetic exception. Divide by 0 is an arithmetic exception. And here is one more method. The method name is add, taking two int parameters, int a comma b, and it is written in int as a written value. And the add method, if you pass two integer values, it will return another integer as an output. And that too, the specifier and modifier prefixes to the method are public and final. That means we can only make use of this method, but we cannot override this method anywhere in the subclasses. Final methods cannot be overridden in subclass. Simple rule. But can be accessed both in subclass and as well as instantiated class. But its method implementation cannot be rewritten. That is what the fact we need to understand. Here, the syntax part is completed. Now we are coming to the consequences of declaring a method as private, default, protected, and public. As you already know, however the variables behave, however the constructors behave, the same way how methods also behaves based on these access preserves. So if you declare any method as a private in class, whose scope is restricted only to that class. And suppose if you write some common method, something like called print, in that if you pass some string as a parameter, internally I'll write system.out.println. Let's see, for example, there is a class called A, and which is having hundreds of methods. Hundreds of methods, each method is having 10 to hundreds of lines of code. The logic is implemented. So throughout the class implementation, we'll write so many hundreds and thousands of lines of code. But in the methods, for the debugging sake, we often write wherever we suspect something, an output or exception or something. We'll for the debugging sake, we'll write system.out.println, and here we'll write some print basis in the system.out.println. Generally, while writing the method implementation, we'll write a lot of debug statements. Debug statements are written with mostly with system.out.println statement. But writing system.out.println statement is quite inconvenient every time while writing, because if you use any IDE, something like Eclipse or NetBeans, you type some starting letters like SOP, automatically that statement will change to system.out.println. But if you're writing on a notepad, if you're writing on an 8 plus or notepad plus plus, so you cannot type SOP and then press control space bar so that the shortcut will automatically expand into system.out.println. Never. So what you do is you write one simple method called public void print. In this you take string message. Internally you write system.out.println. And throughout the class A, in different methods, in different methods, wherever you want to write debug statement, just call print and pass string. That message will come here. Internally we'll write system.out.println so that the developers will get reduce the burden of writing system.out.println statement repeatedly in the program. But still, that statement is used how? Not by typing every time. By writing one user-defined method, private void. And the intention of this private method, the intention of this print method is not to use somewhere outside. I want to use this print method only within my class, within my program, only within my methods of class A. And this method want to be only particularly proprietary to our class. In such cases, you declare method as private. The burden of writing this much length of system.out.println statement will reduce. Simply every method wherever print statement won't involve, print, just pass message, finish. Automatically as that argument will come to system.out.println. So the developer burden of writing, system.out.println will reduce by writing one user defined method called print with access specifier as private. Because our intention of the print method is not to use somewhere outside. It's not any reusable method. It's only just to reduce the code within my program. I've written one proprietary method, my local purpose method. That is print method. Such methods can be declared as private. And coming to the default, see, there is a combination used. Suppose if you write a public class, mostly you will intend to write most of the methods with a public access specifier only within the class, except few methods which do not want to be exposed outside. They will be written as, they will be declared as a private. But most of the public class, but remember, not not all methods of public class are by default becomes public. Never, nobody says. That happens only in interface. In interface, all methods are public. But in class, though class is declared as public, unless you declare methods as public, they are not public. So, public class with public method combination makes more sense than public class with private is okay. Public class with a default access specifier method is of no use. Suppose if you write public class with the default access specifier methods, then that class when used within the package, that public class when used within the package, and that public class when used within the subclass and instantiate class within the package. There we can use that default specifier method. But whenever the class is going outside of the package, there this default specifier method cannot be called. And then in the public class, placing default access specifier method, intention is to restricting the method to be used only within the package but not outside the package. That developer has to choose. Now, then coming to the protected method. I saw a couple of combination of examples in Java where a class provides a protected method. When we derive from that method, we must implement that method. We must implement or override that method. That happens in servlets. It is too early to talk about servlets concept in the core Java. I don't mean, teaching servlets here. Servlet, one example I am giving. In servlets, there is one method exists with the name called protected void service, with servlet request and servlet response as a parameters. This is the method that exists in public class generic servlet. Public class generic servlet. Public class generic servlet is having protected void service method with servlet request and servlet response as a parameters. Into the intention, and this generic servlet class exists in servlets API. Servlets API. It's a predefined API that comes with every web server and application server. If you install Tomcat, in servlet-api.jar, you will get this servlet API. In that you will find this generic servlet. Okay, fine. So while developing web applications, this class is used. While developing web application, if I want to write my own servlet, I'll write public class, hello servlet, extends, I should write generic servlet. When I'm writing class extending from generic servlet, that means this one. The generic servlet asks us to implement the service method. That too, if the method is given as an abstract method, protected abstract void service servlet request comes and response. The moment I derive from generic servlet, because of the abstract, I must implement the method or override the method in hello servlet, no doubt. Because if abstract method is not implemented in my class also becomes abstract. Point number one. Second, see the access specifier. If it is public access specifier method will come here. If it is private, it will be restricted only to generic servlet. If it is default, it will be restricted only to servlet's API package. Because it is protected, the protected member method can be accessible up to subclass outside the package. And now a subclasses are forced to implement service method because of abstract. That because of protected, it came up to subclass outside the package. That is the purpose of protected method. Otherwise, generally, no class contains protected method until unless if the class is intended to override its method in subclasses outside the package. In such cases, only the protected methods are declared. Otherwise, normally in the class, all methods are declared as public. Fine. So now, because we need to implement the method outside the package in hello servlet, we need to implement this void service method. While overriding or implementing, the only difference between overriding and implementing means if already method is implemented in superclass and if we rewrite, then it is called as overriding. In the superclass, if method is declared as abstract and first time when you are implementing the method, then it is called as implementing the method. So whenever we are implementing or overriding superclass method in subclass, the condition is the same superclass method access specifier or its next level access specifier and its higher level access specifier, anyone can be applied. If method access specifier is protected, the superclass method can be overridden as either protected or public. And its same scope can be maintained while overriding the method, or scope can be increased. The scope should be increased, but scope should not be reduced to default or private. That is one very, very important rule you have to follow. While overriding or implementing superclass method in subclass, you override method with the same access specifier or increase the access scope, but don't try to reduce access scope. That is very, very important. If you're trying to do so, what happens? And if you try to override protected method as a default access specifier or with private access specifier, what happens? You will get a special kind of error called weaker access specifier error. And at the moment you compile this class, immediately you will get one compilation error saying that weaker access specifier. There is a method called service with protected access specifier coming from the superclass into your class. You either override method with the same access specifier or increase scope to the public, but not reduce the access scope. This is what compiler will give some little bit description about the compilation error. But ultimately, the error name is weaker access specifier error. Weaker access specifier error. So that is about protected. And what to tell about public? Public methods can be inherited. Public methods can be accessed in both subclasses within the package, instantiate class within the package, subclass and instantiate class outside the package. That is how public is. Now coming to the regarding private, I need not have to discuss much. Private already I have already discussed in the singular classes in the previous video. And default already I said. Protected intention also I said. Now here is an example on protected. Example on protected method access within the package in both subclasses and instantiate classes. There is a package called A. Class name is A. Package name A, public class A, and to show that B and C are also in the same package, I mentioned package name as package A. Public class A, protected word A. So this method can be accessed anywhere within the package. First one, public class B extends A within the same package A, while overriding the superclass method in subclass. As I told you before, same method access specifier can be modified, same method access specifier can be maintained, or its access scope can be increased but should not be reduced. If we try to reduce, which error will come? Weaker access specifier error will come. So you either increase or maintain the same scope while overriding superclass method in subclass. Okay. Overriding protected methods in subclass within the package. Protected methods can be overridden as protected or public in subclass. This is subclass. Here we are instantiating class A and accessing A.A. Whatever logic lies in the A method that will execute. Calling protected method within the package. Note. While overriding methods in subclass, method access specifier scope can be increased but not reduced. If do so, weaker access specifier privilege error will come. Done. Now this is example on protected method access outside the package, both in subclass and instantiate class outside the package. Package A, public class A, protected word A, and the same class and method I repeated again. But in this example, we are having 1, 2, almost 3 classes we are having outside the package. 3 classes outside the package. Public class is now accessed here. Package B, import A package.A. So while importing the class, how to do? Package name dot class name must be written. Import A.A. Package name is B. Public class D extends A. From the class is extended. So method can be overridden as protected or public. It's already done. And the next, in the same package B, I'm writing one public class F. Here I created object of D. From the D also B method is accessed. Otherwise, you write another class called E in the package B. You create object of A and access A method. No problem. But what happens if you're trying to do like this? This protected method is overridden in subclass outside the package. Subclass outside the package. A protected method is overridden in subclass outside the package. Their protected method is overridden as protected or public, and object of D class is created, and through a D, this method is called. Which method? I'm sorry, this method is not B. This is A. D dot A. Into through the subclass object, the D class object, A method can be called. This method will be called. But if you're trying to create object of A, public, because class is public, so A class object can be created. But the moment we call A dot A finish, protected member cannot be accessed by instance class outside the package. Error protected method cannot be accessed in instantiate class outside the package. Finish. And the protected methods can be accessed anywhere within the package. And in the outside package, they can be only overridden in subclasses outside the package. But no instantiate class can access the protected method. That is what important point you need to remember about protected method. Abstract, final, static, native, synchronized. So previously, access specifiers are completed. But here, access specifiers are completed. Now coming to access modifiers. Coming to the access modifiers. Method which is declared but not implemented is declared as abstract. Is it true? Method which is declared but not implemented is called as is declared as abstract. That is what I said previously. I declared some method name called divide or something. Divide. Here the method is not implemented, it is just only declared. Hence, I declared method as abstract. Method which is declared but not implemented is declared as abstract. No method implementation or no flower basis exists for the abstract method. Right. Class which contains abstract method must also be declared as abstract. And if class contains abstract method along with the method, the class also becomes abstract. A class may consist of hundreds of methods, but if class contains single abstract method, then the whole class becomes abstract. But abstract classes need not contain abstract method. I have already explained all these concepts yesterday in the abstract class topic, the previous video. But abstract class need not contain abstract methods. But abstract class need not contain. And without abstract methods also, we can declare class as abstract. Without having abstract methods, how class declared as abstract is generic superclasses. Like yesterday, I've given an example on component class in AWT, which acts as a generic superclass to all its tail classes like label, text field, text area, checkbox, radio button. These UI components are having visual presence, but there is no proper, there is no visual appearance exists for the component. But that component superclass want to act as superclass to all the label, text field, text area, checkbox, etc. kind of components. So hence, classes which are providing such generic implementations also may be declared as abstract. If class contains abstract method, then also class need to be declared as abstract. Abstract methods must be implemented in subclass. This is very, very important. Whenever abstract class is given, what you can do with the abstract classes? You can only write a subclass to the abstract class, and whatever abstract method given in the abstract class, that method need to be implemented in your class. If you don't implement superclass abstract method in your class, declare your class also as abstract. Abstraction importance is to achieve runtime polymorphism that we will discuss in the next coming slide. That is about abstract. Coming to the final also I've already discussed yesterday. Final methods to final classes. Methods which do not want to be overridden in subclasses are declared as final. For example, string class. String class has provided so many methods. Like if you pass some array of characters into string class constructor, like for example Suryanarayana. I don't know how many number of characters my name consists of. Suryanarayana. Double quotation if I write and make it one string. String dot. starts with, ends with, index of, last index of, substring, to carry, get chars, to lowercase, to uppercase, and some other methods exist in the string class. So string class says whatever the implementation I've given for these methods, these implementations are final. These implementations need not be overridden by another class deriving from string class, because string class methods implemented in the string class, they feel that their implementation itself is final. They need not be further improved. It is not something like where client business logic continuously changes, so that method implementation also continuously changes. After all, it is only a manipulation on the area of characters that always remains same. No one will get chance to override these string class methods. So hence, in string class, all the methods are declared as final. But no, actually, string class methods are not declared as final. String class itself is declared as final. Final classes cannot be derived. When there is no subclassing, when there is no deriving, there is no question of overriding. That is what the point I said. If you want to declare all your class methods as final, you better, instead of declaring all the methods as final, you declare class itself as final. No, in a class, if I want to declare 5 methods as non-final and 5 methods as final, then no doubt you can go for declaring only 5 methods as final and don't declare remaining 5 methods as final. So that all, as a developer and designer, you have to, decide. For that's what methods which do not want to be overridden subclass are declared as final. If all the methods of class want to be declared as final, instead of declaring all the methods as final, declare class itself as final. When there is no inheritance, there is no overriding. For a better memory optimization, it is recommended to declare final methods as static also. The same like that instance memory and class memory for variables. Same instance memory and class memory exists for the methods also. Methods which are not declared as static are called as non-static methods or instance methods. For them, the memory will be allocated in the instance memory. Methods which are declared as static are also called as class variables, for whom the memory will be allocated in the class memory. That's what. But not all static methods are final, that's okay. Static methods. Static methods will have only one copy of memory. Non-static methods will have instance methods. Non-static methods will have a memory in instance. Non-static methods are called as instance methods. Non-static methods, memory exists in the instance of the class. Static methods are called as class methods. Non-static methods are called as class instance methods. Its memory exists in the instance. Okay, fine. And the remaining two more modifiers like native and synchronized. Native అంటే like suppose in అంటే the situation comes where I want to write one method in Java, but whose implementation exists somewhere in C or C++. And our Java method wants to connect to the method implemented in C and C++. Methods which want to connect, the Java methods which want to connect to the native methods implemented in C, C++ are declared as native in Java. For that, some little bit story exists. So you write all the C functions, make it into one DLL file, include the DLL file in the wherever the DLL file exists in the system, include the directory in the path and environment variable, and using class loader dot load class, or class loader dot load class, you can give some class name which contains native method. The moment that class is loaded, it will go and link to the DLL file exists in the path environment variable. In the DLL file, anywhere for our method, the matching corresponding native method exists. That method will be loaded into native class loader of the JVM. So it's a big story. So if you implement one example on native method, that example of hardly some 10 to 15 lines of code would be enough to understand native method. That's not a big deal. And coming to the synchronized. Synchronized methods, I can explain you only in the threads concept. In threads, we will learn 3 types of executions: sequential execution, simultaneous execution, and synchronous execution. 3S. 3S execution model is what threads follow. So while synchronizing the methods in threads, there will write the synchronized keyword. So while explaining threads, I'll take example on that. Synchronized methods example. Here is one small example on, here is one small example on abstract method. So how um, the abstract method benefits from yeah, how the abstract method benefits from the normal method. Here I'm writing one class called a public class employee payroll. If you can notice one error here in the statement. Not I haven't intentionally left it wrong. Unknowingly, I mean, mistakenly it happened. I declared method as public void calculate salary. It's a class, it's not interface. In a class, I declared one method, not implemented. I declared one method. Methods which are having only declaration or need to be declared as abstract, and such classes also need to be declared as abstract. These two mistakes I did here. I forgot to declare method as abstract here. I forgot to declare class as abstract here. Okay. The next to this, you know, um, to the abstract class abstract method. See how many subclasses I am writing here. Admin employee payroll, sales employee payroll, production employee payroll. 3 classes. Okay. When to declare method as abstract, why we need to declare abstract method and abstract class and extend that class into child classes, and there we need to implement abstract methods. Why can't directly admin payroll, sales payroll, production payroll classes directly can implement a calculate salary method? Why we need to write one abstract method explicitly in the super class, declare class as abstract, derive that class into our classes everywhere? Hmm? And everywhere the super class forces us to implement calculate salary method. Why all this? Because there are two reasons. If superclass do not force subclass to implement the calculate salary method, however it likes, like however its signature want to be, however its written type want to be, if superclass don't force child classes to implement how the method signature want to be, how written type want to be, how our specifier want to be, we may not guarantee, and there may not be any uniformity. There may not be any guarantee that all the child classes will implement calculate salary method with the same name, same case, same signature. Signature means parameter, same written type, and same access specifier. We cannot guarantee. We cannot keep all clients who are reading the subclasses, sales employee, admin employee, production employee classes. We cannot sync all the developers to write same method with same name, signature, and written types. Unless an abstract method is derived into subclasses and 4 subclasses to implement the method. And a while instruction may not be followed by all the developers who are implementing the child classes, but if you provide one abstract superclass and abstract method and give it to the developers to implement, extend from your class, the moment they extend from our class, they will immediately come to know that there exists one abstract method and superclass, and it implement a method exactly with the same name, signature, and written type. So that is how one way abstract method can ensure the uniformity of methods across in all the subclasses. That is one of the biggest advantage of abstract method. That is one of them. That is one of them. That is one of them. But the example given here is an example on explaining about runtime polymorphism. About runtime polymorphism. Abstraction importance is to achieve runtime polymorphism. That example I am explaining here. Okay. So calculate salary method and the admin employee payroll class is extending from employee payroll. So which method need to be overridden? Calculate salary method. Public but calculate salary. For the this is not the complete implementation of admin employee payroll salary calculation. For the admin employee, what is the general salary calculation logic? And what is the logic exists for the salary calculation for admin employees, number of working days into per day salary. Number of working days into per day salary. As many days attended, those many days into those many number of days salary. That is for the admin employee. But coming to the sales employee payroll, the same calculate salary method, same signature, same written name, same access, everything is same. Only implementation changes. How implementation changes is logic remains half same. So number of working days into per day salary plus number of working days into per day salary plus sales amount into percentage of commission. And apart from the number of working days into per day salary, the sales amount into permission percentage is also calculated and added to the sales employee salary, because we'll give some target of of reaching 1 lakh rupees per month of sales target. If salesman crosses more than 1 lakh, we'll give some 2% or 3% or 5% or 1% of incentive. So that is how they'll get more salary. So apart from their number of working days into per day salary, they will get this additional incentive also, sales amount into percentage. Coming to the production employee also same, the number of working days into per day salary plus for the production employees as many number of overtime hours they work. That overtime hours into overtime amount, as many number of hours they worked into the amount that must be calculated in the production employee payroll. And then for the additional working hours, we need to pay extra amount for the production employees. But this type of logic doesn't apply to the admin or sales employee. So now altogether, how many calculate salary method implementations we got? 3. One copy of calculate salary method is implemented in admin employee payroll, one in sales employee payroll, one in production employee payroll. And the 3 varieties of calculate salary methods are implemented so far. Now the immediate target is we will write a client. In the client, we want to get the employee payroll object. So immediately we get it out. Which employee payroll object we may want to get it. So client wants to get an employee payroll class object, and on the employee payroll class object, he wants to calculate salary method. But the question mark is, which employee payroll object does the client want? So we are having 3 employee payrolls: admin employee payroll, sales employee payroll, production employee payroll. Which employee payroll class object the client wants, so that he will invoke calculate salary method. If you ask a client to choose which employee payroll class object he want, he'll be in a big dilemma. Whether I want to invoke calculate salary method on admin employee, or sometimes on sales employee, or sometimes on production employee. And he cannot concretely say that I want only admin employee payroll object. If sales employee or production employee salary calculation comes, do anybody changes the logic in creating sales employee payroll or production employee payroll class object creation statement logic? Anybody does changes here? Right side? Isn't it? But on the other point, client cannot stick to that. Okay, I'll invoke always employee payroll object dot payroll calculate salary method logic only on the admin employee, or only on sales employee payroll, or production employee payroll. For different employees, whichever department employee salaries, when I'm calculating, some as accountant or some payroll department person, that type of employee payroll object want to be created to me instantly, dynamically. That I don't want to often modify it in the client program. Even I too don't know which employee type employee salary I'm calculating, until unless the employee is passed. We cannot get their department or their designation. So how client will get dynamically the admin employer, sales employer, production employee class object into the reference here? For that, actually this is called as an abstraction example. In this abstraction example, along with one superclass, abstract superclass, along with one abstract superclass, one subclass 1, subclass 2, subclass 3, and to implement abstraction, at least one abstract superclass with more than one subclass. I don't say two, more than one subclass. If only one subclass exists, no need of abstraction. So more than one subclass must exist, and as well as one factory method must be also provided to create objects for any of these employee payroll class objects. Please observe the factory class. The factory class name is EP factory. EP factory means employee payroll factory. Employee payroll factory. Okay? This employee payroll factory class purpose is only to create and return employee payroll class objects. Car factory, only car is manufactured. Bus factory, only bus is manufactured. Coach factory, only coach is manufactured. Employee payroll factory class manufactures only employee payroll class objects. Some factories will manufacture objects of other families also, and that is generalized factory class. So in this employee payroll factory class, I am writing one static method called get employee payroll, whose written type is employee payroll. And then I can call EP factory dot get employee payroll method directly like this here. And but very important point, into this argument, into this, if I pass admin or sales or production, at runtime, whichever argument we passes here, that argument will come to get employee payroll, the static method, and also the static method is called as a factory method. Factory method is the method which produces objects of some classes. Okay, here get employee payroll method is a factory method that is producing employee payroll class objects based on what? Based on the type we are passing as argument here. Based on the type we are passing as argument here. What type we are passing? We may pass admin. That's why admin A capital letter, but here admin is small letter. Here sales is capital, sales is small letter here. Production is P capital letter here, and there is no comparison for that. So, however you request admin, sales or production, I'm just ignoring the case. The type comes as argument here. I'm ignoring the case and comparing if it is admin, and if you're requesting for admin, I'll create in written admin payroll class object. If you request for sales, I'll written sales payroll class object. If you request for something other than sales and admin, I'll written that production payroll employee payroll class object. And the purpose of this factory method is whichever class type you request, the method will dynamically create and return such employee payroll class family of objects. Employee payroll class family of objects means it's shared objects. The two dynamically at runtime, client can choose which type of employee payroll class object he wants, that he can specify at runtime. That type comes here. That type goes here. If it is admin employee payroll. If it is sales employee payroll. If it is production employee payroll class object. This entire abstraction example doesn't exist or cannot survive without without this factory method. So now this factory method is used by the client. Here I am writing employee payroll EP is equal to EP factory dot get employee payroll, static method I am calling. I am passing admin or sales or production. That argument will come here. Based on this comparisons, admin or sales or production employee payroll class object will be returned to client. And that too, here getting employee payroll class object into EP reference, employee payroll EP reference is completely a dynamic. No admin employee payroll or sales employee payroll or production employee payroll class object is directly not instantiated here. That instantiation statement is not directly hard-coded here. It was hard-coded here. Here you dynamically you will be getting employee payroll subclass objects. And if you call calculate salary method, whichever type of employee you ask, that type of employee payroll class object on that calculate salary method will be called. So this type of getting, this is called as runtime polymorphism or runtime binding or dynamic binding. And why it is called as dynamic binding or runtime binding? Because into this EP reference, dynamic binding. Dynamic binding means This employee payroll class reference dynamically gets bound to any of the subclass objects like production employee payroll or sales employee payroll or admin employee payroll. Because of this dynamic binding nature of binding any one of the subclass object to parent class reference is called as dynamic binding. With such a dynamic object, if you invoke the method, the output what you will achieve is runtime polymorphism. And at runtime, you are deciding which class method want to be called. That is called as runtime polymorphism. So that's all about. So this, if you ask client on which subclass object you are calling calculate salary method, even client cannot also decide until he passes admin or sales or production as argument into this client program. Even client also don't know that on which class object the calculate salary method is called. This is called as runtime polymorphism or runtime binding. So we'll end up this session here. We'll end up the session here. We'll end up the session here. In the next session, we'll discuss about some final methods in static and non-static blocks. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.